So problem 6.1.17 is slightly different than some of the other calculation problems we've been doing. So the US EPA places limits on quantities of toxic substances like hexavalent chromium, which has a limit of 0.5 milligrams per liter. If an industry is discharging hexavalent chromium as potassium dichromate, what is the maximum permissible molarity of the substance? So what we have to do is we have to take this concentration that we have of chromium-6, hexavalent chromium, and turn it into molarity of potassium dichromate. And we do that using a combination of molarity, knowing what molarity is, being able to calculate molarity, and reaction stoichiometry. So if we start with 0.5 milligrams per liter, we're first going to change milligrams into grams by knowing that there's 1,000 milligrams in a gram. And then we are going to change grams into moles. Now this is moles of chromium-6. So if I look on the periodic table, the molar mass of chromium is 52 grams per mole. So that's going to be my moles of chromium-6. And what this is going to give me is it's going to give me the molarity in moles per liter, because I didn't do anything to my liters. I've left liters alone. Liters is still going to be there when I cancel out all my other units. And now I have moles and I have liters. That's going to give me the molarity of chromium-6 that is allowed in the sewer system, is allowed to be discharged into the sewer system. And that is approximately 9.6 times 10 to the negative 6th molar. Now, we're going to take that molarity, because that is just molarity for chromium, and we're going to convert that into molarity of potassium dichromate using the chemical formula for potassium dichromate. So if I have 9.6 times 10 to the negative 6th moles per liter of chromium, I can convert that into moles of potassium dichromate, that for every 1 mole of potassium dichromate, I need 2 moles of chromium, and I get that from the chemical formula, the 2 subscript. And so when I do that, I divide by 2, and I'm now going to have moles of potassium dichromate, or the molarity of potassium dichromate. And that's going to come out to be 4.8 times 10 to the negative 6th.